missing, which is a follow-up to the earlier session on low-cost, reliable launch. These were the two areas that came out of a workshop in early June that NASA is really trying to work hard to identify the barriers and then take action to fix those barriers. So that's what this conversation is going to be about. So we have some experts from industry and we have experts from NASA who will join us. I noticed we're missing Doug, but he was going to take a quick break.
Oh, he's taking it.
Yes. So our panel is Dallas Bienhoff from Boeing, who will talk about fuel depots. Also, Dr. Ron Clark, formerly of Lockheed Martin, who's now CEO of Space Orbital Services. We have Dennis Wingo, who's the CEO of Skycorp. And then from the agency side, we're going to have Doug Comstock, who's actually been up here almost all morning, who's the Director of Innovative Partnership Program, and he'll join us when he gets back in. And we have Dr. Rasky, who is the Director of a new group, which is called the Commercial Emerging Space Office, and it's located at Ames, and you'll hear a little bit about that. I have to tell you personally, this is a great conference for me. People probably don't remember or can recall that around 2000, I was leading studies at NASA headquarters, and we weren't allowed to talk about humans above low Earth orbit. In fact, up until the vision for space exploration, we weren't allowed to show what we were doing, internal studies about going to the moon and Mars, about doing things in near-Earth space, because we had to portray a picture that we were totally focused on the space station, though the space station didn't have a context that was greater. So here, it's really exciting to talk about what settlement in space and what our long-term goals are, so we can put it all in perspective. One of the things that we worked hard on was how do you make it sustainable? And even though a lot of us at the time knew that commercial was key to making it sustainable, the agency, even when the new vision came out, was not prone towards what its role was with sustaining an industry or sustaining space exploration in a way that it wasn't all just an agency program. And Doug, welcome back. Sorry to put you back up, but I've already introduced you.
Happy to be here.
So it's really great being at this conference, just being able to have the conversations we're having, and realize that from this particular hour that we're going to spend here, we're going to take away barriers that we're going to have a workshop actually next week from Doug and Charles in Washington to see what we can do about the barriers that are identified. So what I'd like to do is have each of the panelists talk a little bit about where they're coming from and their point of view, and then we'll ask a few questions up here, and then we'll concentrate on questions from the audience, trying to penetrate what the barriers are. So Ron, we'll start with you.
Thank you. I'll use this one. Hello. Again, as Gary said, I'm Ron Clark, now CEO of Space Orbital Services. I've been involved in space services for about 3 years now, starting that effort at Lockheed. But I'm a relative newcomer to some of the people up here and some of the people in the audience in space services, at least work in that area. And in fact, I came across a novel, a 1953 novel, almost 60 years ago, about a space tug that was doing space services. And it's available on Google Books, by the way. So it's kind of interesting to look back and see what people were thinking about 60 years ago. We're still thinking about it in many respects. Space services, I think the time has come, though, that we can actually do this now for a number of reasons. The technology is ready. The market has grown to a very large size, as I think Doug said earlier, or actually Charles, $261 billion of space revenue last year. And that market's very important to all of us. With GPS, communications, a lot of our entertainment comes through space now. We rely on that, and therefore it's very important to us. And these systems that provide that have become very costly, hundreds of millions to billions of dollars each in terms of some of the space systems that are being launched and operated today. What would we do without those? And you can answer that in a different way, each of you would. But it's become much more important to maintain those systems, to keep them operational, and to eliminate outages, and to operate them efficiently and effectively. One of the things the issues there today is when you launch that system, there's not much you can do about it if it doesn't work after you push that start button. You can talk to it and ask it to fix itself, but sometimes it won't listen or can't do what you ask it to do, and most of the time, in fact. So there's an obvious need for space services now to help maintain and support this growing space market that we all enjoy and need in our daily lives. New on-orbit capabilities that can be provided now will change the space architecture immensely. And that's one of the key points I want to make. It is now kind of a launch and hope that it works process, although we do a lot of work to make sure it will work. But with these new in-space services, we can modify or repair or transport or provide a new capability to the existing systems. We can look at different constellations. We're no longer constrained by launch envelopes of mass or volume in the design of our space architecture. We can change the reliability, the built-in redundancy in the systems so that we can modify, maybe build cheaper, maybe build better, maybe build bigger, build different kinds of systems, different kinds of capabilities. So I'll talk about barriers, but we're going to talk about that as we move through this. There are a lot of barriers, but I just want to say that I think the biggest barrier to in-space service today is the market itself. The uncertainty in the market. We've got investors who say they will invest to build these systems if we can validate the market. And I believe if they could hear this group, they would believe that the market is real.
Thank you, Ron. And now, Dennis.
Sure. I'm going to start from a philosophical context and kind of build off the last panel. There is a proverb that, as far as I can tell, is over 2,000 years old from the Arabic world. Trust not to the ways of princes, for their ways are changeable. Trust to the avarice of merchants, because you know what they want. Thinking about NASA, what's changed? You know, to try to change human nature is not what we're about. What we're about is to try to build a business and an industry. I'm going to use a couple of historical contexts, but I'm going to talk about somebody that I worked with who has been a great benefactor of this organization, and through his own mistakes is now a member of Club Fed. In 2001, Walt Anderson came to me and said, "Dennis, I'm tired of dealing with," he called them assholes. "I'm tired of dealing with dreamers. I'm tired of dealing with science projects. What can we do to build an actual business in space?" So we founded a company. Originally it's called GeoMedia because we were looking at selling the Russian Yamal bus spacecraft with Alenia transponders. Well, at the time, the French government was underwriting Alcatel to sell the spacecraft below cost, so that didn't work. But we looked at the market and saw a huge market in geo orbit for extending the life of spacecraft. And that market was proven because there were spacecraft, some of which were already over 20 years old, that had gone well beyond their lifetime. Walt never put more than about $1 million in that project. But in February of 2004, I was sitting in a successful preliminary design review at STEC in Europe, because US companies weren't interested in it, where we had leveraged that $1.2 million into 35 million euros of support from the German Space Agency. We had leveraged that into 180 million euros of support from the European Space Agency and the European government's public-private partnerships. And we did that because we did have a market. We had in the audience that day with us at the preliminary design review a satellite operator, Optus. They were ready to sign a contract with us should we finish the preliminary design review successfully. We did. We were doing that, and we were all celebrating that night when we get word that Walt had been arrested. This is the problem with dealing with billionaires. Sometimes they have their own problems. But our satellite operator, Optus, went ahead, even though they knew we weren't going to be able to close the deal, because when Walt got arrested, everything evaporated. They signed the contract with us because they saw the value. And our elevator pitch in that market was always, For 1/3 of the replacement cost, we can give you 10 more years of life. That's an elevator pitch that all of a sudden any satellite operator you tell that to will go, the wheels start turning, and they'll go, I can make an extra $300 million. Not a problem. Everything else, as they say, is negotiation. We went forward with that, and we were able to close 2 more customers. We actually have signed contracts for almost in the very high 8 figures with customers. The issue is not market. The issue is not NASA. Because I can go, we don't need NASA at all, but there are ways of doing it. The critical issue is, can you build a system for a price that then allows you to charge enough money to where everybody makes money? This is where NASA can help in a supportive role, and Charles Miller said something incredibly good in that context that I think passed by a lot of people, and this is where Elon Musk has been successful. If you walk in the door with your own check, NASA will bend over backwards to help you. But if you're coming to beg NASA to give you money so that you can show NASA how great you are, you're in the middle of the political process. And people talk about crumbs. Let me tell you something, as somebody who gets a few of those crumbs from NASA every now and then, you will be fought just as hard for those crumbs as you will for $1 billion. It's just a different size player that you're fighting against. Everybody's fighting for crumbs. Everybody's fighting for the big bucks. So there are ways of cracking this nut with NASA. I've just reached a success with my own, one of my own patents in this area, in working the markets and working the business. The issue is not today for us, the only barrier at NASA is that we have to walk in the door with something, with an investor. The problem is the investment market and matching good technologists with good investors. And to close, I'll relate a few things. In the 1760s, a guy by the name of Watt went to a steel company elder named Bolton. Watt had a patent on a steam engine. Bolton came with him, funded it. They created a new world. It's called the steam age. In 1804, a gentleman by the name of Fulton partnered with a capitalist by the name of Livingston. Fulton had gone to Watt and Bolton and said, I want to put a steam boiler on a ship and make a steamship. And they said, you're crazy, that's not going to work. Well, Fulton and Livingston got a monopoly from the state government of New York. They were opposed by the union that burned down their first boat, but they built their first boat and started the steamship age. This has been repeated time and time again in history, where a technologist with a good idea that breaks through all the previous barriers, that partners with a capitalist with the vision to partner with this technologist to break the barriers to change the world. We don't need NASA for any of that. We, as technologists, need to convince the capitalists. The capitalists need to look at the ideas and look beyond their own fears and risk and invest in these markets. When we do that, NASA's your best friend. NASA will do anything in the world for you. That is what I want to leave with you.
Thanks, Dennis. Dallas?
Okay, well, I came with a little broader list of barriers, not just services, but the email I got was in technologies for enabling destinations. And obviously one would expect me to talk about depots and depots alone. So let's start a little higher. First, we need to know where we're going. You know, what are our destinations? Mars surface, Mars orbit, Mars moons, NEOs, asteroid belt, etc. Sun-Earth L2 for satellite servicing, human or otherwise. Even the lunar surface. And so those are, you know, once we figure out where we're going, we need to look at the mission. So it's about time and energy. Can we go there fast? Takes a lot of energy. Should we go there slow? Takes less energy. What can we afford? And those time and energy bring up the real issues. Radiation exposure. Dr. Logan's here. He'll talk later today about radiation exposure and the time it takes for us to go anywhere. That needs to be overcome. Propellant mass, i.e. depots, aerobrakes, etc. The faster we want to go, the more propellant we need, the more energy we need. How do we get it there? Life support mass. The longer it takes us to go, the more life support mass we need. How do we offset that? Habitable volume. Do we cram everybody in a submarine? Or do we put everybody in a suite, in a $5,000 a night room on the way there? And how do we do that? Bigelow has taken a great step forward in putting up more habitable volume per launch volume than anybody today. Sustained ops and growth. Once we're there, wherever there is, how do we not only sustain our operations, but how do we grow our operations with indigenous supplies, reducing the logistics mass from the Mother Earth? And Jerry Sadler with ISRU, both for propellant and use of resources for building materials, is a great way to go forward on that. And then human behavior. How do we understand human behavior? How do we change human behavior so we know what we need from a human factor standpoint? Those are some key barriers. So the technologies to address those, for radiation, multi-purpose use of mass that you're carrying with you already. Life support mass, how do you arrange it to protect the crew in addition to the structure mass? Multi-purpose mass, engineered materials that collect radiation, high hydrogen content materials like the plastics we have. High thrust, high energy propulsion. It would be great to have a 1/10 of a G thrust continuous with ISPs over 5,000 seconds to get us to anywhere in 10 days or less. You know, those are barriers to or solutions to solving the radiation problem. Get us there faster. VASMR is a potential down that path. Also, nuclear thermal for a medium stepping point. Aero capture, aero braking, aero assisted descent and landing. How do we use the atmospheres where there are atmospheres to reduce the propellant we have to launch to get to where we're going? Depots are an enhancing path on destinations, but they are an enabling path for reusable space transportation. If we're going to have reusable in-space transportation, we're going to have a way to store, transfer, and move propellant around. If we're going to export propellant from the moon, where are we going to export it to? Who's going to use it? There are companies that want to do that. Shackleton Energy Company, a subsidiary of Stone Aerospace, wants to go to the moon, bring back water to LEO, convert it to propellant for the departure customer. Who's the departure customer? Is it geo missions? Is it exploration missions? Is it a sustainable, reusable transportation system to the moon to support Bigelow's planned lunar base on the moon? That's a customer beyond NASA that we heard yesterday. Bigelow might be driving the launch to Earth orbit rate up to 100 a year. They could drive quarterly or monthly missions to the moon with that same business model. Put up a base, lease it to the sovereign agencies around the world, and have monthly or weekly or quarterly visits to the moon. That drives propellant need. From where? Depends on the price, depends on the cost. Recycling closed or bioregenerative life support systems. Reduce the logistics mass. How do we keep the mass we have and reuse it multiple times? Phil Sadler at ASU and the bioregenerative recycling or life support system. They have a garden down in Antarctica that grows fresh fruit and does it all hydroponically. That's a source of fresh food. Take seeds with us instead of food. Grow seeds on the way, especially the long duration missions. And of course, back to the expandable habitat elements. How do we increase that volume? That's there. I was surprised to see it in the FTDs because just go buy one. Don't spend our dollars developing one. Go buy one. And ISRU for life support and departure and export propellants and raw materials for building up the systems we have once we get there to reduce what we have to bring. Build as big as we want because we don't have to carry it through a keyhole. Psychology and human factors, not much to say there, but I've got one more thing here. Machine shops. We need to send machine shops, not hardware pre-built, because we're going to have to repair them anyway. We need machine shops.
Thanks, Alice. Now we'll hear from the government side. Dan?
Yes, I'm Dan Rasky, and as Gary mentioned, I'm the director of a new office that we've just stood up at NASA Ames called the Emerging Commercial Space Office, or EXO for short. And our office is kind of following on to the space portal, which many of you may be familiar with, where our tagline was the friendly front door to space, because we figured NASA needed at least one. So, and we are supporting Doug and Charles in their endeavors to foster commercial space, and we've actually been helping with workshops and some other things that we have going to identify barriers and the things that government agency can do here to help things along. But I want to give you a little bit of a background, my personal background for those of you who don't know me. Oh, you have that up. I'll tell you what, seeing as we're pressed for time, I think I'll just speak to this. But there is one slide I'd like to get to when I get back. But real briefly, I actually started my career with a small company, Aerotherm Corporation, actually, which was here in Mountain View. And we did R&D contracting for the DoD, largely TRW at the time. And things were good until we got into a program dispute with a big dog, GE, which essentially ate the company. And so I ended up coming over to NASA right in 1989, right during the NASP program, and got my eyes opened by a large government program and seeing the difference from the outside to the inside on those programs. I was also on all the major source evaluation boards through the 90s, through the X vehicle era, X-33 and X-34 and so on. And seeing the sausage being made from the inside, I came to the same conclusion that Charles did about 1995, that the way that the government, the past, it was being forced down to do a lot of its transportation and human spaceflight activities had little chance of success. And thought, okay, there's got to be a better way to make this happen. And I got interested then in commercial space. Okay, what can we do on the commercial space side to kind of help serve as an outrigger for the government programs, so that we can evade getting overturned with the political waves that seem to come through regularly. And so I was following that very closely. In the early 2000s, actually looked very closely at supply of the space station, and we're working with some colleagues at Ames, including Bruce Farber and Lynn Harper. We actually, starting in 2005, arranged several national workshops here at Ames, and looking at the ISS as an entrepreneurial paradigm, which was way before I think ISS was ready for that, but it brought together a whole group of individuals from across the country to look at what could we do with that asset. And we were also then had a fairly significant role with our colleagues at JSC at helping put in place the COTS program, as far as the different model that was being used, which was quite radical at that time. And I have to compliment Alan Lindenmore and Valen Thorne, who run that program, that they were willing to take this new model of other transaction authority and milestone-based approach to roll out this program, which I think has been exceedingly successful from a NASA standpoint, and that we hope is duplicated on several fronts. And so in working through that, we've seen, again, I think the potential for commercial space to really bolster NASA's mission. And that's really, I think, where I'm at, and a number of my colleagues here. We see commercial space, I think, as being a critical part to make NASA much more effective, not less effective, when seen in the right light. And most recently, with support from Charles and Doug, we have organized these commercial space workshops at headquarters. We had one in early June, as Charles mentioned, where we identified 8 market areas. And actually, if we can go to slide, I think it's, if you roll in there a little bit, we have them identified there, which we can kind of have up on the screen, which are kind of handy. Keep going, one more. That's it. And those are the 8 areas. Sorry, the panel members can't see it. But it shows the 8 areas that we came up with at the workshop. And the number 1 priority being low-cost, reliable access to space. And the number 2 priority, which is, I guess, is the topic of this panel, being in-space services. And then we show the other 6, which I think a number of you will be familiar with. But one of the things that we're very interested in right now is then identifying the barriers to development of those different market areas, and also how do they play together to help enable one another. And I've become more and more convinced it's really in the ecology of those 8 market areas, if we can find the right things for the government to do to help foster them, one can aid the other and help spawn, I think, a whole new space industry, with a bright future and millions of jobs and, incredible developments, kind of similar to the internet of this millennium that we'll all look back on proudly. With that, I'll turn it over to Doug.
Okay, thanks. And just to sort of echo the comments here and the comments from the earlier panel, I think one of the key things that we can do to address some of the barriers is to demonstrate success. And there's a skepticism about certain things, and there's a lot of inertia with the conventional wisdom and the status quo. And I like the analogy that Gary brought up of the brother-in-law effect. And there's a lot of that, and we need to start chipping away at that by proving the conventional wisdom wrong. And there have been great examples of this, of some of the renowned experts at the time making statements that a few years down the road in history were just blatantly wrong. And one of the ones that comes to mind, I think, is Bill Gates saying, how would anybody possibly need more than 200K of RAM or something like that? And 640, whatever. But it's hard to predict the future, and you get in a mindset. And the best way to break through some of those is to demonstrate success. And I think create a desire by folks who may be skeptics that once they see success, you open their eyes and they say, I want some of that, and create a market based on that. I think another thing is just sharing information and making information available. And just one thing comes to mind, the last thing that Dallas mentioned, having in-space manufacturing. You may not be aware of this. We have a Phase 2 SBIR with a company called Beck Engineering in Washington State, where they're developing a compact machine shop that could go in space, so you could bring it on a Mars mission, for example, and build what you need instead of carrying all the spare parts with you. And in fact, we're flying that on our next fast flights on the zero-G aircraft in September for proof of concept at zero-G. So there's a lot of stuff like that going on, and I think one of the barriers is connecting all the activity that's underway with folks who may have a need for it. And we're trying to look at information systems and databases and so on to try to help address that. But there's probably a lot more of that we're missing, that there's good opportunity to take advantage of.
That's what I call rapid response.
Great. So now we've heard something about where the different panelists are coming from and some of the positions. I'm going to ask one question, ask each of the panelists to address it, and then we'll go out to the audience, and then we do have also a question from the internet. But I heard different points of view already as we went down the line here, and I'll start with Ron, but what is the role of government? I mean, I heard that from Dennis that, the government can help, but it's not the primary reliever of barriers. And I think this is a question that's really been at NASA headquarters, goes up and down quite a bit, about what our role is at NASA about stimulating the commercial industry. And I don't think we've actually come to a position where we're all in agreement yet. So I'd be interested to hear what your take on that is.
Sure. Okay, I'll just use it. Thank you. I still believe that market uncertainties drive commercial investment in space servicing. There are certain services that when you talk to some of the commercial operators, they say they will buy that if you can get the price point right. And I think that's the one that I believe that Dennis was referring to. And that's probably refueling and life extension and those kinds of, that particular mission. But if you look at other ones where there's more uncertainty in whether or not the government will be a big user of that or will be a competitor in that, then that limits the investor's willingness to believe that they can get a return on investment that's sufficient to warrant the risk associated with the in-space servicing. We went through this and didn't list some of the others. I think things like legal issues, liability issues, engineering risk, and the funding uncertainty. If you're going to have the government as a partner in this, and their budget's going to move around up and down each year, depending on congressional cycles and who's in office and which direction the wind might be blowing, or other important factors, then your business case and your schedules are very uncertain and can't be sufficient to get investors to put money on the table. I've talked to over 100 people in the Air Force, with the insurance industries, with the space operators, with the launch providers, with the satellite builders and manufacturers, and there's uncertainty in every one of those people and business areas express concern about the reliability or validation of the market. Once we operate something and get paid for it, and they see the revenue stream, then that market becomes real, and they will continue to make investment. But until then, it's because it's a new market, there's still remaining uncertainty.
Great, thanks. Two facets here. Restate very quickly.
So some people, like I talked about earlier, 10 years ago, for instance, when I had discussions with the administrator, he would say there is no business case right now for anything above low Earth orbit, and our role is not to, what is our role? I don't want to quote him, but it wasn't a lot of support for commercial industry or starting this, this kind of nascent, important aspect of sustainable exploration.
Okay, I'm going to
So
jump
what is
from
the
there.
government's role,
I'm going to jump from there.
or what should it be?
You were at headquarters at the time. Your boss, Dan Golden. We were working on a Space Act agreement with NASA to do a test of on-orbit assembly technology at the space station. It went through the Wickets and Mark Uran and everybody. We were working, and we'd cut a deal. I'm going to build 6 satellites at the station. NASA, I'll give you 3 if you let me go up there and build 3 and you partner with me. We went round and round and round for 2 years. Nothing happened. Finally, I said, NASA, okay, screw it. Here's what I want to do. I will pay you your entire operational cost for your space station for the number of hours that I need it. I will fly my 1 satellite. I will pay you your standard launch rates on the space shuttle for your space shuttle. Let's make a deal. Dan Golden said, make the damn deal. And when we made the deal, when we changed the parameters like that, when we didn't beg the government for any money, when we were walking in the door with money, it really wasn't that much money. The total operations cost for space stations about $250,000 an hour. I needed it for 8 hours. Big deal. And so we signed a deal. The day we signed the deal, we were going to fly to the station 364 days later on the shuttle. And at NASA JSC, Brian Kelly, who was the head of space station commercialization at the time, walks into the first meeting with all the contractors and all the people at JSC and says, I have direct orders from Dan Golden and George Abbey that your role here is not to tell this man why he can't do his business. Your role is to make it happen and help him make his business happen. That's the different parameter. That is the difference in making a business happen and not making it happen. And I'm going to go back, and Ron said something here, and you talk about businesses beyond the life extension. Well, right now, average ComSat with 36 transponders, KU band, makes about $50 million a year. Okay, I don't need any business beyond life extension to make a business. And every single operator that we ever went to, and I have visited every single satellite operator in the world, I've sat down with every single underwriter in the world. Every single conversation you ever get into says, well, life extension is cool. We're going to make up a lot of money in it. But, if you added robotic arm here, if you did this there, it'd be really cool. And we're going, I tell you what, you're exactly right. After our first $1 billion in free cash flow, we'd be more than happy to adopt all these spiffy technologies. But this is where Walt, after being burned so many times by so many people, had it right. What is the lowest development cost, business that we can get into that actually makes money. The people that are here in Silicon Valley and venture capital world don't give a rat's patootie. They like it. They think it's cool enough. They're not going to write you checks on faith and because it's cool. Some people will, and they do, and a lot of companies get a little bit of money that way. But if you want a business, make it to where everybody wins. NASA comes in. I guarantee Doug knows this. Gary knows this. Dan knows this. You come into NASA with a real business, with checks behind you, you can leverage NASA probably 10 to 1, which is really what Elon Musk has done. Elon walked in the door. Does anybody in this room think if Elon didn't have any money when he came into NASA headquarters wanting to do COTS that he would have won one of the contracts? Is there anybody here to think that? You've got to come in with your own money. You have to have a business that doesn't rely on the government, the favor of the princes, and everything else is negotiation.
Well, it really depends on where you are in the spectrum of where we're going. We heard it this morning, far field exploration, technology, mission systems, that's clearly a government function, and they should play there. Near term, they should buy services and not own the systems, not operate the systems, but buy the capability of taking people or things to where they need to go. That's what COTS is about. That's what COTS Option D was about for crew, should that be implemented. That's what CC Dev, Commercial Crew Development, is all about today, is making that happen. Propellant Depot, the vision said use commercial wherever you can, and the government turned around and said, we're going to do it all ourselves, build a highway that only is going to operate as many times as we want to go, not build it so that other people can use it. They didn't use the opportunity to buy propellant on orbit for the capability. We didn't put ISRU in the critical path. We didn't put we the country. We didn't put depots in the critical path. They can be enhancing or critical. But also, like Dennis says, we may not need the government if Bigelow's business model proves successful. He's marketing his space station to 55 sovereign space agencies around the world. That's a lot of customer base for a space station. And if that's successful, he'll have a base on the moon. And if there's a market that's driving demand, there will be investments to satisfy that demand, and we won't need the government except for maybe some technology enhancements.
Yeah, I think, Gary, I can answer your question with 4 letters, NACA. And actually, we hit on this at the Space Portal a number of years ago. I know a number of people have. When Charles entered the scene, we had a natural ally because Charles had come up to the same conclusion. And if you look back at history, NACA was instrumental in the development of the aviation industry. Again, it was a fledgling industry. It needed help, and Charles actually has a really good presentation that goes through and shows the things that NACA did, and now we recall it for the research centers, of which Ames is one of the initial NACA research centers. We were number 2. Langley was number 1. Ames was number 2. And you had Dryden and Glenn. And so we had the 4 NACA centers. In fact, it's interesting, if you look back at the vision that Eisenhower had for NASA, okay, there's a reason that he hooked NASA up with NACA, because his vision, President Eisenhower's vision of a space industry was one that would grow organically, similar to how NACA had grown the aviation industry. And that whole model changed with President Kennedy in the Bay of Pigs, okay, that he needed something to get attention off of other things, and he jumped on the Apollo space program as a way to, deal with the threat that they saw from the Soviet Union and get the attention off of things which weren't working for him. And when he did that, it fundamentally changed the model that NASA was pursuing. It went from a supporting government organization, which is what NACA was for the aviation industry, into more of a Manhattan-style program. And I think since about 1967, 68, we've been living with the downside of that model, because the problem with a Manhattan-style program is that you need a level of government resources that isn't sustainable, The country isn't willing to put that level of resources in relative to other priorities. And I think NASA has been struggling really since about that time to kind of find a role that's sustainable and produces significant value. I think we're getting closer to it now, but there's still some way to go. But I think if we look back at how NACA operated and how we can emulate that today in today's world, I think that provides a very good model for our interactions.
Yeah, what he said. No, a lot of great comments, and there are a lot of important roles that NASA can play, and it's not a one-size-fits-all. There can be different roles for different deals, different arrangements, different partnerships, and I think we see a spectrum of those. But I think there is real interest in, as Charles said when he made his remarks this morning, we're from the government and we're here to help, and we want to try to make things successful. And part of what we're trying to do within NASA is to communicate to the internal NASA folks why it's in their best interest, why it's in the best interest of the agency. And in the long run, by having a successful commercial space industry where we can, just like we can when we fly out here, buy airline tickets. We don't fly in a government-owned and operated aircraft, and we buy airline tickets. We can buy tickets to get into space for much, much cheaper, have our resources devoted to doing things that nobody else can do. The thing NASA can push the envelope, develop new technologies and things, and in really trying to push the envelope, we look for partnership opportunities that can help further create new capabilities, new applications of those technologies in the commercial space arena and on other things back on our home planet. So sometimes we need to be a customer, a buyer of services, and we can help enable markets. Sometimes we can be a technology partner, technology provider. Sometimes we can be a technical expert. There's lots of different roles that we can play, and we're interested in pursuing the appropriate role for the appropriate partnership.
Great. That was a good conversation. Now we'll take some questions. Paul? Oh, yeah. One second.
One quick comment and then a question. I love that you made the analogy about the steamship and about Fulton and Watt. And just to add to that, at the time, in the mid to late 19th century, commerce on the Mississippi went one way. It went south because that's the way the river flowed. Folks would offload their cargo, and then they'd take the barge and take it apart and use the material. What the steamship enabled is them to offload their cargo, load on another load of cargo, and go back upriver. So it's a great analogy between expendable vehicles and reusable launch vehicles. So I'm glad that you brought that up. But the one question is, and I've noticed this pretty much throughout the entire couple of days here, is we've been focusing mainly, when we're talking about commercial, almost exclusively on NASA. And I just asked the panel to comment on a couple of the other space programs that we have, and that's DoD and the intelligence community. What type of opportunities do you see there? Because Dallas, if you build a fuel depot, I think they will come. And I'm just curious as to what's on the top of your mind about some of the other opportunities outside of NASA.
I'll jump on the fuel depot comment because we include DoD, civil, and commercial in the high energy Earth orbit destinations that a depot and reusable space transportation systems would help. You can take today's existing upper stages, refuel them in LEO instead of going straight into GTO, and double to triple the capability to their destinations, no matter where it is, whether it's GEO, other energy upper state destinations, or interplanetary. So there's a great benefit in just refueling on the way with existing upper stages. We didn't get a lot of traction yet on our discussions with you and the DoD before, but yeah, if we put it up there and we demonstrate the capability, there will be customers, in my opinion.
Yeah, I know that Ron has ideas as well as far as space towns.
Yeah, I just want to say that I was in the Pentagon this week, and the Air Force is definitely interested in in-space services. They're very constrained by their requirements process and their acquisition process, which is a kind of a 10-year kind of a thing from startups. So they really can't move very quickly, but they do want to see this service happen as a commercial capability so they can buy it when it becomes available. And we can put it in place in much lower cycle times than the DoD acquisition process.
Yeah, and Paul, I'm going to jump in here too, because we've had this ongoing discussion now for several years, and privately, the generals would come up and say, Dennis, we love your idea. We love your own orbit system. It would be of immense value to us. We really hope you're successful in Europe because we'll never be able to do it first here. It's the political issue. Again, you're talking to the government. It's the favor of princes. And when an administration changes from one to the other, there's people that see any type of spacecraft that is not an existing spacecraft as a weapon, not knowing that any spacecraft that's up there can be used as a weapon, but it's part of the political argument. So you have to, and Dallas said it, and Ron has said it, if we come up there with the capability, which means someone outside the government has to write the checks to enable the system, we do it. And I want to give you another example because my buddy Rex is here in the audience. A few years ago, we had an opportunity. There was a wayward satellite. If I'd had a check for $4 million, I could have turned that into $150 million within 6 months. When a wayward satellite went wrong, and our little group figured out a way to save that satellite and provide several more years of life in geo orbit. Well, we didn't have that check right there ready to go, and so we lost the opportunity. Again, private money coming to the table, leveraging government assets. And I want to say one more thing on the tech side, and Doug and Dan's exactly right. In a way, I'm like Paul Bryant. My ideas for on-orbit assembly and on-orbit servicing mostly comes from that guy right over there, my good buddy, from JSC, who first proposed that as part of the space station in the 1980s, my good friend Wendell Mendel. And these types of things are all there. But the problem we have today in the private world is capital from the private industry that allows us to leverage and enable the things that allow us to then come to you and say, Paul, I've got my own orbit servicing system. You just had a satellite go defunct. Write me a check for $100 million and I'll go get it for you. That's the difference. And that is what, because we come in here because this group is mostly focused on low Earth orbit, human transportation, the tourism market, and all that's cool. But there is a market out there today. I don't need low-cost, reliable access to space. I already have it. I can go to the Indians. I can go to Arianespace. I can go to whoever. I already have the launch costs I need to make our business plans work. But what we will do in increasing launch rates is to help drive down the prices for everybody. That's what we want to do to help each other as a community, and this is what we as our little community need to look for more things to help each other, because if we don't hang together, we are all going to hang separately, and the NASA budget is a prime example of that. Thank you.
Okay, let's see. Al? I have a question. Is there a niche somewhere for power sets and beamed power in space?
Yes, there is. Actually, myself and Bruce Pittman, and another colleague, Rob Kelso, we actually wrote an article for Ad Astra for last summer where we're looking specifically at needs that NASA has for in-space power infrastructure, both satellite to satellite, and also one very prime need is the lunar surface. If you're on the lunar surface outside of the poles, you have to survive a lunar night, which is 2 weeks without sun, where it gets down to minus 150. And that's a really tough thing to survive. And so having a power infrastructure, power beaming capability would be very useful to a number of NASA missions. And we were actually in this article, Ad Astra Summer 2009, said that by NASA pursuing these technology demonstration for in-space power beaming, we would help drop dramatically the technical risk levels and even the economic risks associated with Earth power beaming, and without having to get into all the the complications when you talk about Earth power beaming, including being the jurisdiction of DOE and a number of other really sticky issues that NASA wants to stay away from, and I think is one of the primary reasons NASA has tried to stay away from in-space power beaming. That said, there is a centennial challenges for power beaming, okay, that the prize is $2 million, I think, or...
1.1, 900K was one.
Oh, there you go. It used to be 2 million, okay.
And you'll hear from the company that won it tomorrow, I think, tomorrow night.
So, and actually, and power beaming was also part of the lunar architecture, okay, before that got kiboshed. But they were looking, I think, at actually from point to point on the lunar surface. But no, power beaming is part of NASA's queue. It just has been pretty low level. I'll just say that.
Actually, I'm going to take a question from the internet here. And this was for Dallas. You might have kind of touched on it a little bit earlier, but it was from Quantum G, and it's a question that says that Dan Adams recently expressed an objection to LEO propellant depots in regard to limited frequency of windows to targets beyond Earth's orbit. How big of a problem is that, and what can you do if you miss any of the windows in LEO?
Well, those windows are reoccurring. If we go to the moon from a high inclination orbit, you can go every 7 to 11 days, something like that. If we go to Mars, it's every 2 years, no matter where you're from.
So you don't see it as
I don't see it as a departure problem. It is an operational complexity to come back to the depot from beyond LEO, from the moon, to get back to the depot to refuel. But it's just an operational issue and a delta V issue.
Okay, great. Yes, ma'am.
Yes, Debbie Lee Wilkinson from the Open Luna Foundation. And I kind of wanted to bring forward perhaps a solution, or at least a strategy that might help expand things, and it is not limited to in-space services. But I think probably most people are familiar with the SBIR program, Small Business Innovative Research. What people may not be aware of is in the post-accounting of the companies that have been funded by this program, the taxes that are paid in by those companies meets or exceeds the money that was actually spent on the entire program, including the ones that failed. And so it seems to me that this is from the congressman's perspective, that there's a money-making policy here instead of a opportunity here instead of a money-spending one. Yes, the money goes out first, but then it comes back. And it seems like this, the types of technology that we need to foster here would fall under those, would follow that same regime, perhaps.
They do. We send a lot of letters of support and interest out to SBIR bidders as Boeing to say whether or not their technology is useful to our products that we have in line. A couple have come in mind related to cryogenic insulation, great for various things. But we do support those, and then we hope to either have a product to buy in the future or have a hand in the development and sale of those products in the future when we do that.
And I think that's perfectly consistent with the administration's overall approach to innovation and entrepreneurship, where by stimulating this engine of economic growth, we're going to create new jobs, create new opportunities, create a larger tax base, and so on. And SBR is certainly a piece of that. And all the things that we're trying to do in investing in new technologies in NASA to help enable new capabilities, new markets for commercial space entrepreneurs, those things are also going to contribute to job growth, economic growth, and ultimately tax revenues.
Yeah, let me just make one comment that if you take a look, feeds the needs. If you take a look at the SBIR program, it is a darling of Congress. I think its funding has been very stable and growing, through the years.
I was sort of suggesting using that as a model in a way to get more money, more of NASA's funds into the private industry.
Let's see. One more. Yes.
Thanks. I'm interested to hear your discussion about markets and the need to validate markets. Dennis spoke a little bit about having customers lined up. If the money had come in, they would be there. And I've also heard internationally, at least in Canada, a big company where the CEO is talking about doing a geosat refueling and servicing mission. They're talking about doing 5 or 10 satellites with one mission. I'm curious to know, what is the threshold at which you think the market would be validated to the point where it's generally accepted? Do you have to do one mission with one satellite? Do you have to have 10 satellites that have been serviced? What's the point at which this is really accepted?
One successful mission, because there's codicils in every single insurance policy written on every single GEO spacecraft that says thou shalt use every mitigation means feasible to mitigate the loss to the insurers. If we are up there, we are a mitigation. The insurance underwriters can require the insurance operators to use our service as a mitigation of loss. And I'll give you an example that's before us right now. Galaxy 15. Galaxy 15, the command processor quit accepting commands in April. The spacecraft has started drifting through the GEO arc. It interfered with, or to keep from interfering, New Skies had to move one of their birds all over inside of their box in the arc. I guarantee you Intelsat is going to be writing some very big checks to New Skies, because New Skies had to waste probably a year's worth of propellant. A year's worth of propellant is $50 million right there. So if we were up there, we could have done that mission for a fraction of that cost and walked away with a big profit. So again, if we are there, and same thing with Paul and the DoD, if we are there and we have one proof principle, we are now in the position to where Paul's bosses can go, I've got a COT solution. Let's write these guys a check. One mission.
I want to comment on that also, because I talked to the vice president of Intelsat this week in his office about Galaxy 15. He said, we don't care. He said, we're not responsible for anything that happens to that satellite once it goes adrift. The policy says we have to move it out when it fails, but we don't have to. If we do our best effort. If it quits, the other guys just have to get out of the way. And we'll tell them when it's coming, and we'll cooperate with them. It's their responsibility to move. So
that's Intelsat's position. What the courts are going to say is going to be different.
The legal issues will come after that, and it'll take years to sort that out. But until there's an enforcement body that can enforce policies, then all of these things are kind of nice to have. When I met with the Undersecretary of the Air Force recently, he said, we have a lot of unfunded policies and unenforceable policies. So that really is an issue that must be resolved by this whole community of how do we treat these kinds of operations in space from a legal liability, total aspect.
So we're coming to the end. I've just got a signal here, but there's one last thing I would like to ask at least the industrial participants here on the panel, because next week we're going to be talking about this internally at NASA headquarters. Can you tell us explicitly what barriers you would like to see NASA work on that they could overcome or do things that would actually help stimulate this industry?
Gary, absolutely. And just like they were talking yesterday about launch services, if NASA says we're only going to buy 8 seats to the space station next year, that doesn't encourage the space launch industry to provide a lot of capability. But if NASA would say we're going to use space services, we're going to buy this kind of service, and here's the kind of capability that we need, and here's the price we're willing to pay, and here's how often we're going to buy it, then it's easy to get a business case and to say, yes, I'm going to get a good ROI if I can charge this much money, and it only costs, I have to drive the cost down below what you're willing to pay. And that's an engineering and program, a business requirement. But if NASA will make a commitment, and not just NASA, but DoD, as you said, Paul, and Intel community, to use services and buy them at a certain rate if they're available, not necessarily just from anybody, but just from the commercial community, then the investor community will provide the money to go do this.
Thank you.
ITAR.
Okay.
Seriously, when we were doing our effort and we were in Europe, I was the chief engineer on a European on-orbit servicing system project. It is by its very nature dual use for military uses. My brain is a controlled item by the U.S. government. In our ITAR TAA agreements, I could run the team, I write the requirements, the contractors come back and tell me what they design. I could only answer the requirement. The Reagan administration had a great policy. It was called free trade with free peoples. And we did this in the computer industry. We could sell any computer we built, the absolute best computer that we had, we could sell it to anybody that was a friend. But if it was going beyond the Iron Curtain, we had to sell 2 generations back. What this did, it was still better than anything they had, which kept them perennially behind us, but at the same time, it allowed us to have a global market of our friends. It's stupid to have TAA agreements with Australia, Canada, England, and the Netherlands. What are the Dutch going to do? Bomb New York? So, ITAR.
To limit it to propellant depots and the greater metropolitan Earth, which was a George Brown comment, which is between the moon and Earth. Market assurance. Find a way to buy propellant, as an example, the way you bought cargo to station. 150 tons, 300 tons, 450 tons a year to orbit is a lot of market for today's launch vehicles and future launch vehicles. Buy rides to the moon to enable a reusable lunar transportation system along with the other sovereign agencies in the world. Those go hand in hand.
Well, at this point, yeah, we'll be talking about it next week. I want to thank everyone for participation in this panel, and hope you got something out of it. This has been a great morning, so thank you very much. Please thank the panel.